Okay, so today we are moving on to dealing with quadratics, and nothing here is going to be something new that you haven't seen in Algebra 2, but we're going to go over everything again. So our objectives are going to be identify the properties of quadratics from all three forms of the functions, and we're going to graph them, okay? And then we're going to write quadratic functions when given the vertex and a point. All right, so let's look at the three forms of the quadratics. Okay, so the first form is a standard form. So it's f of x is equal to a times x squared plus bx plus c. So remember, a and b and c are, numbers, like your regular numbers, and your x and your y's are there still. Okay, so when you have this form, just know that quadratics are polynomials, so the domain is all real numbers. Okay, so here when you're given this, A is your vertical stretch or shrink and the vertical reflection. Okay, so it reflects across the x-axis. And you guys need to know this based on the transformation lesson. All right. Um, and you have negative b over 2a, that is your axis of symmetry. Okay, and that's going to be very helpful in graphing your function. And then the last part, the c, is your y-intercept. So let's look at an example. I have f of x is equal to 2x squared plus 4x plus 1. And I know I might be going fast. So when you're watching these videos, you should pause and take notes. Okay, guys, actually take notes so you can look back at them. And so here I have a standard form. I'm going to start out with the axis of symmetry because that is very nice, right? So I have my A, B, C listed. A is 2, B is 4, C is 1. And my axis of symmetry is negative b over 2a, right? So negative 4 over 2 times 2, which gives me negative 1. So axis of symmetry is just a line, right? X is equal to that. So there it is. X is equal to negative 1. I'm going to put a dashed line because it's not part of the graph, but it's helping me. It's going to help guide me in graphing this, right? So um, I have a dashed line on x equals to negative 1, and I know that it's symmetric. That's what it means. The axis of symmetry divides the graph into two symmetric sides. So it has to look exactly the same on both sides. So for it to look exactly the same on both sides, I know my vertex is right in the middle. So my vertex is exactly on this. Okay. So to find the vertex, I know that the x value, right, the x coordinate of the vertex has to be negative 1 based on the axis of symmetry. All right, so to find the y, to find exactly where it is on this, I just plug in the negative 1. So here, I put negative 1 in for x and I solve for y. All right, so all I did was take my function and put negative 1 in for x. And then, order of operations, you solve that. Y comes out to be negative 1. So now I know my vertex is negative 1, negative 1. So there is that point. I got my vertex. Right, so from here, there are many things you can do. Right, if you just look at A, based on the transformation lesson, A is positive, so it did not get reflected. It still opens up. Okay, it opens up. And then because it's 2, it's getting stretched vertically by a factor of 2. So instead of a regular pattern of 1, 1, 2, 4, 3, 9, a pattern that you must remember, by the way. You need to memorize that. Quadratic is 1, 1, 2, 4, 3, 9. But now it's getting multiplied by 2, so all the y values get multiplied by 2. So it's 1, 2, 2, 8, 3, 18. Okay? So you can do that. You can put a point at 1, go over 1, go up 2, go over 2, go up 8, go over 3, go up 18. Okay, that gives you points. But you can also use the last point, which is the y-intercept, right? C is the y-intercept. So C is 1, so my y-intercept is 0, 1. All right, and if you want to see how that works, all you do is you put 0 in for x, like so. Oh, actually, there's the y-intercept, the point there. So I put 0 in for x, you see. So these two terms disappear because it's 0, so I have y equals 1. That's how I got that y-intercept, because C is the only value remaining when you put 0 in for x. So y-intercept is 0, 1. And it's important that you see how that works. Okay, so now I have my vertex and a point, and I have my axis of symmetry. So I know that I am going to have a point exactly the same on this side because it's symmetric, right? So if you see here, the distance here is 2, right? So I have exactly the same thing over here. Distance is 2, so I have another point there, right? So that point just happens to be, oh, whoops, I didn't change that coordinate. It should be negative 2, 1. But you guys get the point, all right? So I just forgot to change that. So there's my graph, right? I got 3 points, vertex, got the graph. We good. All right, let's go vertex form. Vertex form is in this form. Okay, so when they give you vertex form, you know the vertex. Oh, you know A is still the vertical stretch, shrink, and the reflection, and the vertex is H and K. Okay, remember this is X minus H. So whatever value you get here, your vertex is going to be the opposite of that. And that should be intuitive based on the lesson on transformation. Okay, whatever is next to X, it does the opposite of what it says. It says minus, you go to the right. So that's why it's a positive H for your vertex. Okay, so let's look at an example. Here is a function f of x is equal to negative 2 times x minus 1 squared plus 3. Right away, you see, oh, I have my vertex already because it's called vertex form. It's easy. The opposite of this, which is positive 1, and this number, which is 3, there's my vertex. Boom. Okay. Now, if I look at A, it's opening down because it's negative, right? See, it reflected, so now it opens down. Okay. So basically flipped across the x-axis and vertical stretch of 2. Now, based on that, let's do the pattern. A normal pattern would be 1, 1, 2, 4, right? 1, 1, 2, 4. But now it's multiplied by 2, so it's not 1, 2. So if I go over 1, go down 2, I have this point. I go over 1, which is back to 0, down 2, from 3 down to 1. That's a point. Okay. If I go over 2, oh, because this is symmetric, so that's another point over here, right? So you guys see that. But there you go. If I wanted to go over 2, I would have had, instead of going over 2, 4, I need to go 2, 8 instead, because they got multiplied by 2, basically. But just one of them is enough, and now you have 3 points. You can graph that. Okay, and the last form is called the intercept form. And obviously, intercept form should give you the intercepts, right? But this is what it looks like. A times x minus p times x minus q. And when you're given this form, the intercepts, the x-intercepts, oh, x-intercepts is going to be p comma 0 and q comma 0. These numbers, the opposite of these numbers, give you the intercepts, okay? Because remember the property of 0, you take this, you set this equal to 0, you solve for x, you get q, you know. So it gives you 0 for y, basically. That's why it's the x-intercept. But there's your x-intercept, and a is still your vertical stretch, shrink, and reflection. So an example, f of x is equal to negative 3 times x minus 1 times x plus 3. Here, right away, you see your intercepts. Opposite of this number would be 1, 0. Opposite of this number would be negative 3, 0. So there are my x-intercepts, okay? So based on the x-intercept, I can find my axis of symmetry because it's right in the middle, right? Axis of symmetry is right in the middle, so I can go in the between these two. It's somewhere right here, probably. Right? You can eyeball that. Count 1, 2, 3, 4. So 2 would be in the middle. So it'd be right here at negative 1. But if it's harder, if it's some weird numbers that you can't count, you can do this, right? To find the midpoint of the 2 points, basically just add them and divide it by 2. So x is equal to negative 3 plus 1 divided by 2 gives you negative 1. So there's my axis of symmetry right there. So my graph, the vertex is somewhere on here, right? So to find the vertex, again, I put in negative 1 for x because that's where the axis of symmetry is. Plug that in there. I got y is equal to 12. And there is my, oh, that point shouldn't be there yet, but who cares? This one is my vertex. Now, based on my point A, now, if you have 3 points, you should be pretty good for the graph. You kind of know exactly, or not exactly, but you know a very good idea of what it looks like. It curves like this. But if you want more points, you look at A. A is negative 3. So negative means it opens down, and 3 means you go over 1, down 3, go over 2, down, let's see, 4 times 3 is 12. See? That's what it is. So there's my graph. All right. Now you have to be able to convert from standard form to vertex form. Remember, standard form to factored form, you can just factor it, right? Or intercept form, you can factor it. But to vertex form, it's a little bit harder. One of the methods is called the completing the square. So here's an example. I have f of x is equal to 2x squared plus 12x minus 5. Oh, whoops. So first of all, you group the first two terms, the x squared and x together. And then I'm going to factor out whatever's in front of x. I want the x to be just x and no number in front. So I factor out a 2. And what's left inside is x squared plus 6x minus 5. All right. Now, looking at the red part here, I want to complete that square. I want to make that into a square. So I need to add a number in the behind here. And completing the square, remember perfect squares, they're a thing. So you guys got to look up what perfect squares are if you don't remember. But I know the number I need to add is 9. And that is because I take 6 divided by 2 is 3. 3 squared is 9. So I got to add 9 to the red part. So I add 9 to the red part. I got to add some or subtract something to balance that equation. So nothing changed. Now, if I put 9 here, it's 9 times 2, which is 18. So I added 18. I got to subtract 18 to keep it the same. So that's all it is. I got to subtract 18 in the back, add 9 there. And then I factor out this perfect square. The whole point is to make it a perfect square so you can factor it. X squared plus 6x plus 9 is equal to x plus 3 squared, right? So here I have x plus 3 squared. The 2 still in front. Negative 5 minus 18 is negative 22. And there's my vertex form. The other method is to use the axis of symmetry. So A is 2, B is 12. My axis of symmetry is negative 3 because of negative E over 2A. So here my vertex is a negative 3 and something. So I plug that in, put that in for x. I get y is equal to negative 23. And my vertex is negative 3, negative 23. I plug that into the vertex form. So there's my vertex form. I need to put x into here, y into here. So I have x minus negative 3, right, guys? Minus negative 3, so I got plus 3. And then minus 23, so plus k, plus negative 23, so minus 23. And the a is already there, a is 2. All right, last thing we have to do is to find the equation when you're given a vertex and a point. So let's check out this graph here. They gave us vertex and a point, so I know my vertex is 1, negative 5. So I put that into my vertex form, right? So x is 1, so I put x minus 1. Y is negative 5, so I put that in here, minus 5 back here. So, but I need to find the a. That's why I need another point. If I don't have this point, I can't find it. All right. So, but I know this point is 0, 3, so all I do is plug in 0 in for x, negative 3 in for y, like that. 0 for x, negative 3 for y. And I solve for a. Basically, this is negative 1 squared, which is 1. 1 times a minus 5 is negative 3. So I add 5 to both sides. A is equal to 2. No, a is equal to 2. All right, so there you go. I plug that back into here. I have my vertex form. F of x is equal to 2 times x minus 1 squared minus 5.